Mistakes happen. All right. Well, let's get into the stuff then from today. I want to talk a little bit about, so last time we talked about multiplying polynomials together, and we used that FOIL method. And so today we're going to talk about how to undo that method. So whenever there's a way to do something in math, there's always a way to undo it. All right, so that's what we're going to talk about on 5.8. Now it's called factoring. All right, so we're going to be factoring polynomials. So let's look at some things here first of all. If we have, I want to talk about the greatest common factor, because that's one thing that we could be doing. So sometimes all we're going to be doing is factoring out the GCF. The greatest common factor. All right, and remember, greatest common factor just means the biggest number that will divide into all of the number that you're looking at. Okay, so if I have something like this, let's do negative 5x to the 4th plus 10x to the 2nd minus 25x. And so it's asking me to just factor this, and what I need to look for first is how to factor out the greatest common factor. And one other thing that you've got to take notice of is if this leading term right here is negative, we want to factor that negative out with it. Okay, so that's always something that we're kind of looking for. If it starts with a negative, that negative is going to come out. Okay, so I know that part's going to come out, and then I can see, all right, 5 will divide into all of those numbers. So 5 is going to be part of our greatest common factor. And then we got to look at our x parts, right? Well, this guy only has one x to give. And so that means that's all we can take out of each of these, right? And remember, I mean, since we're undoing this, we're trying to like divide. We're trying to figure out what would divide into this, right? Each of these different terms. So our GCF is that negative 5x. And so you're going to take that and you're going to divide each of these terms by negative 5x. All right, and so on the outside, this is part of our answer, that negative 5x is on the outside, but then inside here, and what I'm going to have in orange, are our leftovers. So if I divide out a negative 5x, what's left here in this term? Anybody know?
What would be the equation?
X to the what?
Third.
Yeah, x to the 3rd power. Right? Because again, when I multiply these back together, they need to come back up with what we had there, right? So if I multiply negative 5x with x to the 3rd, you get back to that. Okay? Because remember, when we have an x to the 4th divided by x, we're like subtracting those exponents. Okay, let's look at the next term. So again, if I divide this term by negative 5x, well, 10 divided by negative 5 is negative 2, and x squared divided by x is just x. All right, and then my last term, again, I'm dividing by negative 5, so negative 25 divided by negative 5 is a positive 5, and then the x's divide out. And so this is what I would be left with for my answer. Make sure you keep that negative 5x as part of your answer. All right, that's your GCF part. These are your leftovers, but together they make your answer. A factor, when we're talking about factoring, if we have like, just break it down to something easier. if we have 3 times 5 equals 15, right? 3 and 5 are the factors because they're the things that are connected by multiplication. And 15 is called the product, the answer to a multiplication question, right? And so these are connected by multiplication now. We got negative 5x is one of my factors, and then the x cubed minus 2x plus 5 is my other factor. Okay, what questions can I answer on this one? We're going to do another one with greatest common factor, but was there anything here that was kind of tricky that, again, I'm not sure where she got that from.
I don't get the x part. Like, I get that you're dividing out everything, but I don't get how you're getting the x's.
Okay, well, so think about, so if I was to write this out, that negative 5, and that x to the 4th means 4 x's there, right? And say that again. Oh, you're not talking to me. So there's 4 of them there, right? And then on the next one, there's only 2. And then on the last one, there's just 1. So we have to think of what's the largest amount of x's that could divide into each of these. And so it's just going to be x because this guy only has an x to give. We can't divide, like if I was trying to divide that by negative 5x squared, do you see that there's not going to be, like you're going to be negative 1x there. So you can only, and it always is going to be, the variable with the lowest exponent, if you want to think about it that way. All right, so the GCF with the variables, thinking about the variable with the smallest exponent, because that is all it has to give. Oops. Okay, so let's look at this next one. This one's a little bit more involved, but I want you to first, I'm going to give you some time to think about it, and I want you to think about what do you think the GCF would be. All right, so take it one number at a time and then one variable at a time. So if I ask you to factor out GCF, here's my instructions, of 18, let me change this, x to the 4th, y to the 3rd, minus 27, x to the 3rd, y to the 3rd, plus 9, x squared, y to the 3rd. Okay, so I want you to sit and think for a minute. So think about these separately. What's the biggest number that will divide into each of these? And then think about your x's separately and your y's separately. Okay, when you come up with just the GCF, not the whole answer, but what the GCF is, I want you each to type that in the chat box, what you came up with. And remember, don't press enter yet. Okay, but just type it in and I'll tell you when to press enter. And if you're trying to raise something to a power, so if I had like something like 2x squared y to the third, I would write 2x, and then you do that little caret, right, to say it's raised to that power. Okay, so that's how you would write it in if you have some powers and stuff on there that you're trying to put in. Okay, so I want you to use the chat box. I want you to type in what you think the GCF is for this one. Okay, it's not this. This was just an example of how to type it into the box. Okay, and then when I tell you, we'll all reveal our answers. So hold on a second. Let me give everybody a chance to get that put in. Just the GCF part. Okay. Is ready? You have that, just the GCF. What's the GCF of this? Okay, ready to type it in there. And then 3, 2, 1, press enter. All right, so we've got a few different answers here, it looks like. So I want to just talk about which one these are. I think these are all of the ones that I see. Yeah. And that's helpful for me to see like what you're thinking the answer is so that I can clarify anything for you there. Right? So it looks like, I mean, well, all of this is kind of similar, but let's figure out which one is correct. So we have 9 and -9. So those are what we chose there. Why did we take the -5 out on this one? And do we need to do it on this one? Anybody remember why we said we're going to take out the negative there? Hello?
Would it be the smallest variable because it's negative?
But I'm just talking about the 5 part, right? Why did we take out the -5 and not just 5 on this first example? Because I'm trying to decide, is it 9 or is it -9, right, that we're looking at to take out. So why did we take out the -5 here?
Is that because we need to keep the last part to be positive?
Yeah, we want to take out the negative so that this first term here becomes positive in our leftovers. Because what's going to happen is we're going to take this, and sometimes we can factor this orange part further. And so it's going to make it much easier to move on with this if that first one is negative, okay? So since this was already positive, we're just going to take out a +9 on that part. Okay, so 9 is part of our GCF. Okay, what about x? I see an x to the second, and I also see x to the first. Which one would it be? Would it be x to the second or x to the first? That's part of our GCF. And why? Like, tell me what you're thinking there. Emily, what did you think?
I just said x to the second because that's how many x's are in the last term at the end of that.
Okay, and if we're looking at the exponents of all of our x's, right? We've got 4, we've got 3, and we've got 2. And so we always want to pick the one with the smallest exponent that's available, right? Okay, so that's going to be our next part, is x squared. And then it looks like everybody that at least chimed in saw that every single one of these has a y to the third, so that means y to the third is also going to be part of our GCF. Okay, so this is the GCF, but before I do the factoring part, I want to make sure, does everybody understand that, or what else can I clarify on why that's the GCF? Okay, so what we're really going to do from here is we're going to divide each part by the GCF to see what is left over, right? So you don't have to write this underneath here like this, but for some students it really helps them to see what's happening and what's left in each of the different terms. Okay, so let me scroll this up a bit. So we said our GCF, I'm going to put that in blue again, this is still part of our answer, right? Our GCF is 9x squared y to the third, and then our leftovers, I'm going to put next to it in parentheses. So in my first term, right, 9 divides into 18 twice. With my x to the fourths, right, I've got the 4 minus 2 is 2, so x squared is left there. And then my y's just cancel out. Y to the third divided by y to the third doesn't leave anything there. Okay, then let's go to the second term. 9 divides into 27 3 times, so don't forget about that negative there, right? So minus 3. And then my x terms, I've got 3 on the top, 2 on the bottom. So subtract those. I'm still left with 1x there on the top. And then my y to the thirds again, just divide out. Okay, on this one, 9 divided by 9 is 1. You don't have to put that 1 in there, but I'll put it there just in case so people can see where that went. And then my x, or actually in this one you do, because there's nothing left here. The x squareds divide out, and the y to the thirds divide out. And so then all we're left with in that term is just 1, right? 1 times 1 times 1 just gives me 1. And so then this whole thing is my answer. And if to check it, I could just distribute that back through, right? Do the distributive property. And then if I did that and I started with, or I came up with what I started with, what I was trying to factor, then I could see I did it right. All right, what else can I clarify there in that example? Yes, you do. Thanks for asking that. Because remember, when things divide out, it's not 0 that is left, right? 9 divided by 9 is 1. X squared divided by x squared is 1. Y cubed divided by y cubed is 1. And so we're doing 1 times 1 times 1. So you've got to leave that 1 there on the end. Because do you see, if you didn't have it there and you tried to distribute back through, there would be no last term. You would just get these. You get that 18x to the fourth, y to the third, and then that second term, but you wouldn't get that last term. Does that make sense what I'm saying? If you multiplied that back through?
If you multiplied it back through, it just wouldn't exist anymore if that plus 1 was there.
Exactly.
Okay.
Yep, that's exactly right. Okay, let's look at this one. This one might be a little bit easier to swallow. Let's try this. So what if I have 21x to the third plus 14x squared plus x? Okay, so I want you guys to try this from start to finish. So figure out what is the GCF, right? Factor that part out and then put in leftovers in parentheses next to it. Okay, so if we're looking for the GCF, right, we're going to start off with the number part. So 21, 14, and then this one's just really a 1 that's there, right, an invisible 1 that's there. And so what is the largest number that will divide into those 3?
Just be 1, right?
Yeah, just 1. Right? And then if I'm looking at my x parts, right, I got x to the third, x second, and then x to the first, so then that means x is going to be the other part of my GCF, right? So really, my GCF is just x. So if I divide x out of everything here, all right, if I divide this by x, I'm left with 21x squared. If I divide that second term by x, I get 14x. And then x divided by x is 1. So that whole thing together is my answer. Okay. All right, we're going to shift gears a little bit, and I want to ask you, I'm going to kind of just ask you a few things with just kind of a little game almost. Some of you are going to be like, oh, this isn't a very fun game, Becky. But hopefully you'll think it's an okay game. All right, so what if I asked you, maybe I'll just write this down a little bit here. It's a number game, so yeah, it's not like a video game, but well, I guess it is because you could see this on video. But not the kind you'd like, right? But what if I asked what multiplies to be negative 24 that adds to be positive 2? That's what multiplies to be negative 24 that adds to be 2. So we're trying to think of which two numbers. So what two numbers multiplied together gives us this and adds to be this? Okay, what do you guys think? Okay, yeah, so positive 6 and negative 4, right? So if we're thinking what times what is negative 24, you know, if we went through all of our possibilities, because sometimes on this you'll have to do that. What times what is negative 24? Well, that'd be like negative 1 times 24. Maybe negative 2 times 12, right? Negative 3 times 8, right? Negative 4 times 6. And then, but that negative could have went with either the first number or the second number, right? But only one of my numbers could be negative for it to be a negative number, right? And then this would be the only one that I looked at that multiplies to be negative 24 that adds to be a positive 2, right? So negative 4 and positive 6 on that. Okay, what about if I said what multiplies to be negative 20, right, that adds to be negative 8? I don't want to have to write down all the words again, but what multiplies to be negative 20 that adds to be negative 8? And then, so you're putting it in the box there, in the chat box. See a negative 10 and 2, right? So negative 10 times positive 2 gives me negative 20, but when I add them together, negative 10 plus 2, it gives me my negative 8. So that's what I'd want, is negative 10 and positive 2. All right, so that's kind of what we're going to be using today to do some of the next factoring, is we're going to be thinking about these kind of thing. What multiplies to be this number that adds to be this other number. Okay. And sometimes, like I said, you might have to list out kind of like all the possibilities. So work organized. Start with 1. 1 times what? Then go to 2. Is there 2 times something? Is there 3 times something? Is there 4 times something? 5 times something? So on. Okay. All right, but let's look at an example here. This is what they're going to look like. And they're just going to say to factor. We're going to factor the trinomial here. Remember, trinomial means it has 3 terms to it. So if I have this one, x squared plus 9x plus 18. All right, so we're thinking here what multiplies, right? So we want to know here what multiplies to be this number that adds to be that middle number. All right, so multiplies to be that last number, adds to be the middle number. And notice that this is written in descending order. The highest exponent, then the next highest, and the next highest, and so on. Okay, and so we're going to just be factoring these trinomials. So we'll take this, what multiplies to be that last number that adds to be the middle number. Okay, so what multiplies to be 18 that adds to be 9? What do you guys think? All right, so if I think about all the different factors, 1 times 18, 2 times 9, 3 times 6, this is the only one that adds to be 9, right? So when I write this down in factored form, this is what it's going to look like. All right, we're going to be making 2 sets of parentheses here. And so I'm going to first ask myself, what times what is x squared? Well, that's x times x. So it goes in the first spot of each of those parentheses. And then the next part is going to come from what we found with our little game here, right? What multiplies to be this last number that adds to be the middle number. And so we said a positive 3 and a positive 6. Right? And so this would be our answer. Right? But if we wanted to check it, we just multiply it back together. We could FOIL it. Right? So x times x is x squared, x times 6 is 6x, 3x, and then 18. Right? So x squared plus 9x plus 18. And that's what we started off with. So yep, that's for sure. This is the way it factors. Okay? And there's only one way that these can factor. But you could write your parenthesis in a different order. If you wrote it as x plus 6 times x plus 3, that's fine because multiplication is commutative. Right? It doesn't matter which way if you do 2 times 3, that's the same thing as 3 times 2. Okay? So it doesn't matter which way we write that. All right, let's look at another one. How about this one? Let's do this next example. Oops. Let's do x squared plus 2x minus 24. So go ahead and get that all put in factored form. And then I want you to type it into your chat box. There you have it there. And then just wait a second until I tell everybody to so make sure you put them in parentheses like I'm asking you here. Okay, write your answer in your chat box. And then 3, 2, 1, press enter. Okay, and so being a positive 6, right, and a negative 4. And some of you have the x minus 4 written first and your x plus 6 written second, and it doesn't matter. There's not like a better way to write it or whatever. It doesn't matter which one you put first, which one you put second. Okay, so that's all we're doing with these type here. Let's try another one. What if we have y squared minus 4y plus 3? All right, so let's factor this one. And again, when you get your answer, type it into your chat box, but don't hit enter yet. All right, so we're trying to think of what multiplies to be a positive 3 that adds to be a negative 4. All right, so when we're thinking of 3, well, there's really only, 1 times 3. But remember, to get a positive answer, we could do a negative 1 times a negative 3. All right? And that still would give us a positive 3 for our answer, right? Or we could have positive 1 and positive 3. Right? But then which one of those is going to add to be our negative 4? All right, so go ahead and write that in there. Okay, make sure not to hit enter until I tell you to. Okay, but go ahead and hit 3, 2, 1. Let's hit enter. Okay, that's the way that would factor on that one. Those would both need to be negative on this. Okay, let's look at this next one. This next one looks a little bit different because there's 2 different variables in it, but we're still going to do the same thing that we've been doing, right? So don't let those 2 variables throw you off. So if I have x squared minus 9xy plus 14y squared, right? I'm still trying to think of what multiplies to be this last term that adds to be that middle term, right? But we notice that there's an x and a y already, on there. So when I'm thinking of this, remember I said to get x squared, that's going to be x times x. And to get y squared at the end, then I know that I'm going to have a y and a y. But I also have some numbers in here I've got to be dealing with too, right? So I'm thinking what multiplies to be 14 that adds to be negative 9. Well, that would be, 7 and 2, but one of them needs to be negative or both of them needs to be negative. How do we figure out what we're going to have, right? Well, we need a negative 9, so both of those end up being negative. Negative 7 times 2 is positive 14. Negative 7 plus negative 2 is negative 9. All right, so I'll put minus 7y and then minus 2y. So that y there just looks really weird. We just end up having, another variable at the end of our numbers there. But it really, we're going about it pretty much the same way. But what questions do you have on that one? I know it looks different.
So why is there an x on the original equation on the negative 9?
You mean the middle term?
Yeah, that middle term.
Yeah, so let's just check this and FOIL it back, because doing the FOIL helps you to see that a little bit better, where that's coming from. Right, so if I do x times x, that gives me x squared. X times negative 2y is negative 2xy. Right, when I do this times this, I get negative 7xy. And remember, it doesn't matter if you put yx or xy, but usually in math we just write it in alphabetical order, so that's why I'm putting it that way. And then negative 7y times negative 2y, negative 7 times negative 2 is positive 14, y times y is y squared. And then if I combine those back together, right, x squared minus 9xy, because those guys are like terms, plus 14y squared, then I can see, oh yeah, right, that is that same middle term that I would come up with. So so that x and y, right, are both there because we have an x and y in each of our factors there. Does that make more sense? Sometimes people just look at the the inside terms and the outside terms. So if I just did that here, right, this times this is negative 7xy, and this times this, right, is negative 2xy. And so those have to add to be that middle term. Yes, no, maybe? Does that make sense?
Yeah, that makes sense. It just looks more confusing than it was.
Yeah. And like I said, sometimes when you do the check, you're like, oh, okay, I can see where that's coming from now. But yeah, so it looks really weird when we have two different variables, but you're still kind of focusing on, what's the last number, what's the middle number, to help you figure out what the factoring is going to look like. Good question. Thank you so much. I'm so glad you asked that. All right, let's look at this one. So this one is going to say factor completely. Right. And so it starts off with 3z to the second power minus 24z plus 45. Okay. Okay, so one thing is you're factoring, one thing that you're going to always want to look for is if there's a greatest common factor that can divide out of each of the terms, because that's going to make the rest of the factoring a lot easier to do, right? Because we haven't talked about what do we do when there's a number in front of that like z squared term, right? And you're going to talk about that more in other classes and stuff, but I want you to see that there is a greatest common factor that can come out of these, right? So 3 is the greatest common factor, right? And then the leftovers, right, would be z squared. If I divide this by 3, I get negative 8 z, and then 3 divided into 45 goes 15 times. Right? But then I'm not quite done yet. So we've done these separate. We did the GCF on one, and we did the factoring trinomials on the other. But there's going to be some problems where they're meshed together. So when it says factor completely, make sure you look to see, is there more I can do? All right. So now I'm trying to think, could I factor this trinomial into these two different parentheses like this? So what times what is z squared? That would be z times z. What times what is 15? That adds to be negative 8. Okay. So you come up with negative 3 and negative 5. right? When I multiply those together, I get positive 15. If I add them together, I get, oops, I meant to put negative 8 there, negative 8. All right, so that means I'm going to have negative 3, right? So z minus 3 in one, and then z minus 5 in the other. But make sure when you put your answer in, don't forget about that 3 that's out in front. This is still part of the answer, okay? Still part of the answer. All right, one more question, and then we're actually going to be done for the day. That's why I didn't take a break, because I knew we were going to kind of finish up a little bit early. But if you have, you know, questions and you want to stick around, I'm more than happy to answer questions for you guys. Okay, so let's try this one also. So what if we have x squared, or sorry, 2x squared, no, sorry, x squared plus 5x plus 8. Okay. Okay, so on this one, we're trying to think of what multiplies to be 8. Well, that's 1 times 8, 2 times 4. Is there anything else? Nope. So these are our only possibilities. Do either of these add up to be 5? They don't. So that means that this cannot be factored. But you want to make sure that you exhaust all your possibilities, because sometimes people think that something can't be factored, but they just didn't, you know, list out all of the possible factors that could be there, and so they miss one. But these are them. That's all we have. 1 times 8 is 8, 2 times 4 is 8. I mean, we could do the negative numbers, I guess. Negative 1 times negative 8, and negative 2 times negative 4, but still, none of those are going to add to be a positive 5. All right, so basically, we need to say that this one, it's not factorable. And the word that we use to say something is not factorable is we call it prime. So if you have on your homework some that do not factor, then you're going to call it prime. And there's probably not going to be a lot of them that are prime. So if you end up you're like, oh man, all of these are prime, you know, then you're doing something wrong with your factoring. You know, there might be 1 or 2 on there that don't end up being able to be factored, but most of them will be able to factor. Okay. Questions on that? How we can tell that's prime? Does that make sense?
I have a different question.
Yeah.
For the group quiz, posted on. I wasn't like that.
Sorry, say that one more time. Couldn't hear you.
Quiz. Is that posted online? Because I wasn't able to write down all the questions.
Yeah, it is. So if you go into, let me see, I'll find it on there. I don't want that to feel big, but that's okay. So yeah, so if you go into the modules, and I get down to module 5. Oops, I went too far. All right, then you'll see that there is the module 5 group quiz right here. Right? And I wasn't able to show all of them on the screen last time either, so make sure you get all of them on there. And so you can work on this together with other people. I mean, if you guys, you know, haven't exchanged information, you can do that with each other, but if you don't want to exchange information, you know, necessarily, then you could just go to the discussions, right? I thought I had chat available for you guys. You know what? I'm going to go in and change that so that you guys, because there is a chat option that you can, that I can make available for you so that you guys can just kind of chat with each other and stuff too. It might be a little bit easier. So I'll just put it there below modules, and then you should be able to get in there to chat with each other on it too. So that's just another idea. Okay. So then if you go into it, so now it's there. So if I go into chat, it'll just look like this. And then usually, I guess you can only chat with the people that are there. But if you go into people also, oh, is that not? Sorry, I needed to change some of these things because for my online classes, I always have them available, but where you guys were not originally an online class, I had this kind of separate. But let's see, why is this making it so difficult? Let me do one more thing here. So let's put people out there also. Usually you guys will just talk to each other in class, but since that is not an option these days, let me do that for you. Glad you brought that up. All right, so then if you go into people, so this is where you could just message each person. Like, so if you know somebody in the class and you only know the first name, that's fine. Just, you know, I want to go in and talk to Kate, and so I can click on that. I don't want to click on it here because I'm not sure on my view if it's going to show you like the person's grade or something like that. So yeah, but you can go in there and do that. Okay. All right, guys, if you have some questions that you want to stick around for, I'm more than happy to help you with things. So otherwise, that's all we're doing for today. That takes care of the rest of Module 5. So that means you need to complete all of the Module 5 this weekend, and then you're going to be doing the review online, and then there is also going to be a quiz, the Module 5 quiz that's due next week. So make sure you're getting all caught up with all your homework done on Module 5 up to 5.8, which is what we covered today. Okay, guys, have a great day. Stick around if you have some questions. More than happy to stay and help, okay? Have a good weekend. Bye.
Becky.
Bye. See you guys.
I have a question.
Sure.
It's a 5.5 question, and it's like the cubed root of negative 125 and then times x to the 18th power.
X to the 18th? And it's a
Yeah.
cubed root?
Yeah.
Okay. So remember with cubed roots, you can get an answer on it. You can't have the square root of a negative number, right? Because that gives you a no solution because we're thinking what times what gives us negative 16. Well, there's no two numbers that I could multiply together that are going to give me a negative. But if I multiply three numbers together, right, I could. Okay, so what do you think here then? What times what is negative 125? And you can just, there should be a cubed root button on your calculator. Sometimes
Is it negative 5?
it is. Yep. So if you did, right, negative 5 times negative 5 times negative 5, right, you get positive 25 times another negative 5 gives you that negative 125. Okay, so negative 5 comes out, right? What about my x to the 18th? So we just said we would take what our index is here, right? That's that 3, since it's a cubed root. And we're going to use that. We're going to divide that by this power. So we're doing 18 divided by 3. which is what?
6.
6. So that means 6 x's, or, x to the 6th power gets to come out.
Okay.
Because this is telling us how many groups we get to take out. When it's a square root, we're doing things in groups of 2. Right? So if I had, so say that I had this. All right, then I can see, okay, well, if I rewrote this, 2 times 2 is 4, and then x squared is x times x, y to the 3rd is y times y times y. And so I'm taking things out that are in pairs. So 2 gets to come out, x gets to come out, and y gets to come out. But then there's a y that's still stuck inside. So sometimes you'll have some questions where not everybody gets to come out. There's something still stuck in there. All right? And if it's cubed root, then then you're doing groups of 3. If it's a 4th root, you're making groups of 4.
Okay.
Does that make sense? So that's why we're dividing this, because, I mean, we could sit there and write down 18 x's, right? But that's going to take a long time. But when you did that, you'd be like, okay, well, how many groups of 3 do I have in 18? And that would be 6. So you end up with there.
All right.
That makes sense?
Yeah, that makes sense.
Okay. Good. I'm glad. Is there anything else that was tricky?
No, I think that was the only one I was stumped on just because it was a cube root and not a square root.
Okay. Yeah. Yeah. And if there might be sometimes that on some of the homework they have some that are 4th roots and stuff. And remember, just make groups of 4, right? Or you're dividing that by 4. So if this said, let's write down something else here. Let's say that it said y to the 23rd power instead.
Okay.
How many y's get to come out?
Would it be 7?
Mm-hmm. Yep, because you're just thinking, right? You're doing 3. How many times will 3 divide into 23? 7 times. With how many left over? Right, so I'm just looking at, I want to think about my division like this, not as a decimal, but 3 will divide into 23 7 times. Right, 7 times 3 is 21, so then I'm left with 2, right, that remainder of 2. And so that's how many y's are still stuck inside. So I still have a cubed root, right, of y squared. Because there wasn't, I need to have groups of 3, and there's only 2 of them left there.
Okay. Okay, that makes sense.
Reach out to me if you get stuck on any of the other ones or have any other questions come up. Okay.
All right.
Okay.
Thank you so much.
Have a good weekend. Bye.
You too.
Okay, bye.